feeders. When we're doing the loads, Monday we were doing our lighting loads. I'm sorry, not here. We're doing our lighting load. Talking about lighting loads, I gave you that assignment for the bank and the lighting loads, and I guess our final was 37,000 or whatever it was. And then what we're going to do is we're going to add these receptacles. We're going to add these receptacles. This is a store up here, so that was something different. But you have the assignment with the bank, and then you have the assignment with the receptacles with these loads on it. Okay, this is all going to size the feeder that we're putting in. Okay, where's the feeder go? Okay, and what are we looking at? So here's our telephone pole, here's the transformer, goes down to the meter, goes to the service disconnect, then it goes to the main panel. Off these main panels, it would go to our branch circuit. Never mind to this, I'll get to that in a bit. Okay, this over here. The other sizing of neutral. Neutral only has to carry what the load says, or if it's over 200 amps, you rate it 70%. Okay, so that's that. Get back here. Conductors between the service and the equipment. Branch circuit over current device. So again, here's our branch circuits. Here's our feeder. This has to carry whatever's in this panel, has to be carried by the wires going back to the meter. Load dependent on total power requirements of the system. Okay. So what does it require the system? What's being plugged in? Lighting, power, motors, air heating, air conditioning, water heater, whatever else they got. Whatever is being plugged in is your total power requirement. Factors for correcting the feeder size, type, and overcurrent protection. The factors, what are the factors? Well, we got voltage drop. We can have voltage drop. You got a long distance, meters on one side, panels on the other. Who knows? Heat. Instead of going, you may be going in a hot attic. Instead of in a hot attic, you may be going on the roof, not exposed to sunlight. So these are corrections that we do have to make on that wire. Before we get to that. The other thing is materials. The feeder can be copper and aluminum. Location. The environment around the feeder, damp, hot, corrosive, must be considered. So when you're running, where's this raceway going between your service disconnect and your main panel? Okay, is it a corrosive environment where you have to change the type of conduit you use? So like when I worked in the slaughterhouse, meat packing place, they killed 1,500 to 2,500 pigs a day. All our conduit was aluminum. Why? Well, some of them, because they use water to clean everything down, and the other were coolers. So there was average around 42 degrees. Okay? So you can't have condensation build up on these condos. These condos get rusted and then it gets on the meat. So that's why we used aluminum. Aluminum doesn't rust. Wiring method. The feeder can be ran conduit, cable, tray, or other systems. Cable, single or multi-conductor can be used. The feeder type can be parallel or individual. Well, what's parallel, what's individual? You know, there is no wire. Let's say I got an example here. How do we size a feeder? Well, power divided by voltage equals my amp. So I just give you an example here. So now I got 742 amps. I go to table 31015B16 and I go down all the way to the 2000 kc mils, and that wire does 655 amps. I got 700. The last thing is I want to be messing is with a 2000 kc mils. I don't like messing with 4-aught. More or less than bigger wires. Even though I've done it before, not fun. You know, so I would put them in parallel to downsize my wires. The length for voltage drop, I talked about that. The derating factors. Conductor size and includes several factors: conduit fill, ambient temperature, and correction and load demand. So that's the correction factors. The neutral wire may not be necessary with a feeder. Okay, what does it mean by neutral not necessary with a feeder? So let's say we have a 277 480 delta coming in. So all we have is 3 hots, which is going into the building. But and then we're setting a transformer, our own transformer, so the utility transformer, we're setting our own transformer and knocking it down to 122.08 3-phase. Okay, so they don't bring a neutral in. They just bring 3 hots. And we pick up the ground off the grounding. Okay, they just, now we set up our own transformer and they take it in. And then now we have the neutral. That's where we get off the transformer. That's where we get our grounded wire out of. So we go from a delta to a Y, 122.08 3-phase. Demand factors. Continuous loads may affect feeder. So demand factor. What's a demand factor? That's a table where if you have a dwelling, a hospital, a hotel, motel, and a warehouse, so you can derate. So it's a demand factor. You can change the demand factors on those areas. Okay, we got a bank or a store, we do it at 100%. Protection. Various overcurrent protective devices can be used with feeders. You can use breakers, fuses. Commercial service computation procedure. How do we do the procedure to find our service type? So determine the general lighting load based on the total square footage, multiply the voltage, indicated in table 22012. Okay, so we did that already. So we had a bank, we used 3, we got the square footage of the bank, and we multiplied 3.5, and then we added our sign lighting, show window lighting, we added the receptacles for the show window, we added the parking lot light or whatever else we had, and we added it all in. If the lighting is continuous, do it 125%. Section 21020A. For the feeder service loads, use table 22042 and apply the lighting demand factor required for types of buildings. So there's that demand factor. Okay, so where was it? Here it is right here. So the lighting on the demand factor, if you have dwelling, hotels, motels, hospitals, warehouse. We got a bank, 100%. After computing both air conditioning and heating load, omit the smaller of the two, section 23060. Okay, so that's what you were doing here. Sorry. So that's what you were doing here. Okay, so you have to find what is the size of the heating, what's the size of your air conditioning. And then omit the smaller of the two. You're only going to use the larger of the two. Compute receptacle loads, multi-outlet assemblies. If you have a plug mo, it's got a bunch of little things. So for every 5 feet, you do 180 VA. Every duplex 180. Every single 180. Show windows. The unit load. For your you do your receptacles depending on how many feet you have with the show window, and then 200 VA per foot of the show window. And again, it's section 22014. Heavy duty lamp holders at 600 VA each, according to 22014E. Others as outlined in section 22014. Applying the demand factors shown in table 22044 for receptacle load. Okay, so here, got some of you questions back already. So here, okay, so I got I got 58 receptacles. Some of you didn't derate. If you're over 10,000, you derate the receptacles. So you get the first 10,000 100%. Anything over 10,000, you do it at 50%. Then you add that half to the 10,000. That is your new derating load. At the sign lighting, 1200 VA minimal, section 22014F. Compute the motor load using the approximate tables in Article 430. So here we have 2 motors. Okay, so we would go to table 430, 248, or in the uglies is page 34, because these are single phase. You can tell it's single phase because it's a 120, 240. Rarely do you see a 120, 240 in a three-phase system. So this would be a single phase. I'm hoping y'all would have caught that. Increased motor, if you got two motors. So some of the questions were, okay, because I got two motors, do I multiply one times 250%, 125% and add the other? No, because these are two separate motors. Okay, if this blower was with the AC, even though it works, because this blower is either for the heating or the air conditioning. Okay, this has its own protection, this has its own protection, this would have its own protection. This will come on when this comes on, but it's not protected by that. So this is a separate motor by itself somewhere else. It just blows the air across. And then this one is the exhaust fan. So I got two different motors. So each one would be done as a load. So I'd have to find this 125%, find this 125%. Using the guidelines given in section 250.24c, size the grounded service conductor. Be sure that the grounded service conductor is not smaller than the grounding electrode conductor. So 250.66. So what it's saying is your neutral, I got 150 amps. Guess what? I don't have to carry the same one out. Why? Because that neutral will never see this 150 amp load. I got a 150 amp breaker, so I got a 1-aught wire to carry 150 amps. I got a number 3 wire from a neutral. Why? Because if I lose this 100 amps, I got 70 amps on the neutral. If I lose the 70 amps, I got 100 amps on the neutral, so I have to size it to the load it has to carry. So I can download it. In the thing it says, I'll get into that later in a bit. But what I was talking about is your grounded wire can't be smaller than your GEC. So your grounded wire, which is your neutral, can be smaller than your GEC. Providing there is no discharge lighting, the neutral load, on the neutral load. If over 200 amps can be derated by 70%, refer to section 220.61. Okay, so 220.61, you can't derate your neutral. Before I get over here, computer receptacle loads. Again, you can derate the demand factors on receptacles. Again, if you're over 10,000 amps, 10,000 VA, you can derate. First 10,000, you get 100%. Anything over 10,000 is 50%. And your kitchen equipment loads, again, depending on how many pieces of equipment you had. I got 5 pieces of equipment. Okay. I get it all multiplied up, add them all up, and then multiply by 70%, and then boom, that's my demand load. That is my new demand. That's my new derated demand. Okay. So if I got 5 pieces of equipment, add them all, multiply them, add them up, multiply by 75%. That's it. That is table 220.56 is on page 156. 177, I'm sorry, 177. Okay. In the book, you have, so we're putting all this together. Okay, once we come back to this question here. So I'm just giving you a number. So I'm saying the formula is I equals P divided by E. Current equals power divided by voltage. So here's my voltage, here's my power. I divide my power by voltage, gives me 742 amps. Okay, I couldn't find a wire in the thing, but I go back to 310.15b16 and I look, and let's say I want to run 3 parallel runs, so I divide it by 3. So I would have 3 parallel runs at 250 kc mils in each parallel run. So that's where we're talking about the parallel runs. So again, your feeder would be between, say, the main panel and your service meter, even going up to your things, because your meter size accordingly. Okay, so this is your feeder right here, going from the service disconnect to the panel. We're going to put all that together. So next, now that you got your lighting loads, you got all your general lighting loads. Okay, divide that by your applied voltage, and then that gives you your amperage, and again give me a wire size. So give me a wire size. If the wire size, it's pretty good, a pretty large size number, you maybe want to do it in parallel. You can. Remember, when it's in parallel, it has to be a size 1/0 or larger, and they all have to be the same length. Okay, so always remember that. So in parallel, it has to be 1/0 or larger. So if you want to put them in parallel, so you give me a conduit size, wire size for that feeder. Okay. So what size conduit, what size wire? If it's only a single wire, well, it has to be able to carry that wire. If you decide to put them in parallel, what's the 2 parallel runs? Just like I said here, I did here. I did this one here. I multiplied 178,265 VA divided by 240 gave me 742. I said I was going to put 3 in parallel, so I divided this by 3, and it gave me 250. I think it was about 250, somewhere around there. Almost 250 amps. So I divided, so that was a 250 kc mil, if I remember correctly. Yeah, 250 kc mil does 255 amps. So that's how I got this answer here. So I want you to do the same thing, but I want you to turn around. Table 4, table 5, find me a wire size. So how many wires are you going to have in that conduit? 4. So your feeder size, remember, if your load is over 200 amps, you can size your neutral 70% less. You can eliminate everything. Your neutral will be 70% less. Okay, so if you're over 200 amps, your neutral is 70% less. And so your neutral can be smaller, so that means that you're going to have 2 hots, and then a grounded wire or a neutral wire, which would be one size. And then you go, from there you go to table 250, 122, and find me your grounding, because I want you to pull a 4-wire system, 2 hots, neutral, and a ground. Okay, we did grounding last chapter, so now we're going to add 250, 166, table 250, 166, 122, 250, 122, find me a grounding wire for whatever amperage you come up to. Okay, I'll put it in, I'll type it all up and I'll stick it in an email. Don't forget the cahoots for your night guys. It's due today, and my day guys is due tomorrow by noon, because you're getting this at night, so I'm going to give you the average, the thing for in the morning. So make sure you get all this down. Again, I'll put all this in an email. I'll get it all out. So we're working on the same bank. Everything that I've given you is for the same bank. So we figured out the lighting. Now we figured out the power. Next step is figure out the feeder size and conduit. 4 wires, 2 hots, neutral, and the ground. I'm sorry, I forgot to go here. I'll add the sign lighting, compute the motor loads, increase the largest motor by 125%. That's if both of them are on the same breaker. Our 2 motors are on separate breakers, so that doesn't count to the motor we're doing. Size service and service conductors. Size the grounded service conductor. And then you can derate the neutral by 70% if over 200 amps. Our grounding, once we get the ampacity, okay, how do we find the amps? VA, watts, divided by voltage gives us amps. So once we have the amperage, we can go to table 250, 122, it's also in the uglies, table 250, 122, and find our grounded wire, not a GEC, not a grounding electrode, but our grounded wire, grounding wire that's going in the conduit with our neutral and 2 hots. Alright? And then I'll type all this. Y'all have a good one. Don't forget your cahoots and any other work that you haven't done. Again, this I'll send it an email, and the test, I will release the test tomorrow, Thursday, and that'll be due by Monday morning. Okay, or by Monday, I'm sorry. Well, by Sunday night. Okay, so I'll release it tomorrow night, so you'll have the weekend to do the test 12. I'll send it an email tomorrow, Plus, tomorrow I'll open it up on Schoology. Again, everything so far that I've sent out, all of it is on Schoology. So if you can get on Schoology, go to Schoology and you can download whatever you need. Okay, in case you can't find it. Some of you had problems with the PDFs, so the PDFs are all on Schoology. You all have a good night and enjoy. Okay? Peace.